Hi everyone. Today we are going to talk about 9.1 logarithmic function, log functions. So we'll be able to find the log functions from the exponential functions by using inverse functions and draw the graphs. Okay. So what is log? Log function is the inverse function of the exponential function. So we learned about the inverse function many times, right? Inverse function is what? Reflection over y equals x line, right? You reflect over the y equals x line and then get the other function, right? That's the inverse function. So we learned how to find it, but now we know, so exponential function, you should remember, and log function, they are inverse function to each other. So when you find the inverse function from exponential, it will become log function, and log function becomes exponential function, right? So now y equal to b to the x power is an exponential function. Then how do we find out inverse function from here? So let's follow the steps. Inverse function is what? So reflection over y equals x. How do we find it? We switch x and y, right? Y becomes x, x becomes y. Then that will make the function be reflected over y equals x line. So y becomes x, x becomes y. So this function and this function, they are inverse function each other, right? So problem is y is in the exponent. We should change this, convert to the the standard form of the function, which is y equal to something, right? So how do we change this to the standard function, which is equivalent to this one? So that we should learn now. It's not difficult, just very simple step, but just remember, exponent power goes down, power goes down, and same base, power goes down, same base, all right? And then the third one, x will be, in the parentheses. But just take a look. Power, y is in the power, will go down. So y equal to, all right? So y will go down. And then we know that exponential function become log function, right? When you switch it. So when you switch it, change it to log. But remember, in the exponential function, this is the base, right? Base, exponent, base, exponent, or the power. But in the log function, we call this is the base. So the easiest thing to remember is we use same base. So this base goes to the base for the log function here. So power goes down and then change it to log, same base, and then what is left? X in the parentheses. And we are done. This is the log function. So y equal to b to the x. And if you find the inverse function from here, y equal to log bx. And done. You can put this in the calculator and you can draw the graph. All right? So y equal to log base argument. We call this argument. Doesn't matter. So x is the go to the parentheses, becomes argument. But power goes down, same base. Just remember two things. Then the rest go to the argument place, parentheses. With example, y equal to the 2 to the x power. The graph goes like this, right? Exponential function graph. We want to find out inverse function. What do you do? What is the first step? Switch x and y. So x becomes, y becomes x becomes y, so x equal to 2 to the y. Oh, now this is the inverse function, but we are supposed to write down as a standard form y equal the rest, right? Y equals something. So how do you change this to the standard form? So y must go down, right? The power must go down. Then when we change this form to, what happens is exponential function becomes log function. That's it, right? So y equal to log, and then what do? Same base, use the same base. Base was 2 here for exponential function. When these two base becomes the same base in the log function here, right? So let's do y equal to log 2, and then where does x go? Only this place. You are done. You can use this function in the calculator, and that's it. Not log was the first, you saw the log for the first time, but you just remember log function is the inverse function of exponential function. Then that's it. All right. So now we know, we learn how to change, get the inverse function from exponential function, also how to convert these x equal to b to the y, and y equal to log of bx is equivalent, same thing, same function, right? And this is inverse. So x equal to 2 to the y is equivalent to the y equal to log of 2x, but they are inverse function of y equal to 2 to the x. All right. Then asymptote, we learned about asymptote, right? In the exponential function, we had a horizontal asymptote, which was x-axis, y equal to 0 line. The graph never touches, right? This one, we learned it. But now, log function is inverse of exponential function. Everything is opposite. X and y switch. X value becomes y value. Y value becomes x value. Just switch. So what happens is this horizontal line becomes vertical line here. So y equal, let's draw the graph for y equal 2 to the x and y equal log 2x. Okay. So if you draw it, this is, we learned this one, exponential function, right? I just drew it. So when x is 0, 1, and it goes, each time goes twice, and half, but never touch the horizontal line. But now what happened to the log function? If you put this in the calculator, in the graph mode, and look at the table, you will see like this, right? You will see this blue one is for exponential function. This red is for log function, right? So when x is 0, error. So look, there is no negative value here, right? For y value in the exponential, then which means there will be no negative value for x values in the log function because inverse function. It never touches horizontal line x-axis. It never touches y-axis in log function. So when x is 0, error, right? So vertical asymptote. That's why error. When x is 1, y value is 0. When x is 2, y value is 1, right? And then when x is 3, 1.585, but decimal, I recommend you to just find out only the integer values. So when x is 4, y value is 2. So when x is 4, y value is 2. You plot the point. Next is when x is 8, y is 3, but it's out of range. You don't need to. Now when you draw the graph like this, and then it goes down like this, right? Never touch this vertical asymptote. As exponential function never touches the x-axis, come close but don't touch. This one also come close, don't touch. All right. That way you are going to draw the graph. So you go down, down, but never touch. That's it. That's the graph. You understand? So this, you can read this. So where do we use log function helps to shrink the numbers of, the very high magnitude to a smaller one, which our brains can deal with easily. So you can read it, but we'll finish here.